Hi guys! Welcome back to another week of Science with Miss Sanjana. I hope that you and your families are safe, happy, and healthy. Today we're going to be doing an experiment that we had done in after school, but we never got the chance to finish it. Some of you might remember that we had discussed the question, can water walk? I want you to take a few seconds and think about this question. Is it true that water can walk? Well, in after school, a lot of you had discussed that water can move. We see it flowing through objects and flowing into our cups and glasses, so it's true that water can move, right? And in a previous video, we talked about how water molecules move all around and they bump into each other, which allows it to flow. So what do you think? Can water walk? To figure out this mystery of if water can walk, we will need some paper towels, some water, 7 cups, and food coloring. BTW, I was so happy when I found the food coloring we had to use in after school. The first step is to line up your cups just like this. I used all different ones. Step number 2, you're going to fill cups 1, 3, 5, and 7 most of the way up with water. Here comes the fun part. You're going to be using your food coloring. I'm using blue, red, and yellow, but you can use whatever colors you like. And if you don't have food coloring, that's okay too, because we can still see what happens and if water can walk without food coloring by just observing the water itself. Starting with cup number 1, you're going to add 5 to 10 drops of red food coloring. Then, when you finish, go on to cup number 7 and do the same thing. This is how your setup should look like after you finish adding the red food coloring to cups 1 and 7. Now go to cup number 3 and add in 15 drops of yellow food coloring. Do you guys remember you had all said this looked more orange than yellow, but as we kept on adding the food coloring, we saw that it kind of looked a little bit more yellow. And you see here, this is how your setup should look like after adding the yellow food coloring to cup number 3. For our last step of the food coloring part, we're going to add 5 to 10 drops of blue food coloring to glass number 5. And this is how the setup should look like after you've finished all your food coloring. It looks so pretty. Now you're going to take a paper towel, fold it in half, then fold it in half one more time, then fold it in half again, and you're good. I was struggling. Now, take that paper towel that you just folded and fold it in half so it'll be easier to put into our cups. Using the paper towel that you just folded, take it and put one side of it into the cup with the food coloring and the water, and the other side into the empty cup. You're going to repeat this with the remaining cups. That way, the same thing happens where one side is in the cup that has the food coloring and the water, and the other side is in an empty cup. This is how your final setup should look like. Now we wait and see what happens between those cups. What do you think will happen? As we saw before, as soon as we put the paper towel into the cup with the food coloring and the water traveled up the paper towel. And as you can see here, well, it might be looking a little bit slow, but when you put it in the first time, it rushes up the paper towel. After a few hours, I thought it was so cool how the empty cups ended up having almost the same amount of water as the cups in which we had originally put the food coloring and the water. But why did this happen? How did the water get into the empty cup? We didn't put any water in the empty cup. Well, let's find out. What we saw happen is something known as capillary action. Capillary action is the process in which a liquid moves up something solid or a material with a lot of small holes. In our experiment, our liquid was the water, and our material with small holes was the paper towels, because remember, paper towels are absorbent. They have those small holes in them to be able to absorb liquid. Capillary action happens when 3 forces called cohesion, adhesion, and surface tension work together. When this happens, the water molecules are considered to be cohesive, or they stick to each other, and they adhere or stick to the paper towel. So as the water molecule moves up the paper towel, it pulls the other molecules with it. Therefore, the molecules pull each other along, and guess what? It goes into the next empty cup. So what do you think? Have we concluded that water can actually walk? Well, we can say that water has moved or walked along the paper towel into the empty cup. Isn't it so cool to see how the cup that had nothing inside of it is now filled with water? It's like we did some sort of magic, but in this case, it's not really magic, right? It's science. It's called capillary action. See how amazing science is? I hope you guys enjoyed this week's video, and please do leave me a comment if you try this at home and let me know what happens. I'm super excited for you guys to try this experiment. I hope that you enjoyed it, and for those of you who didn't get the chance to finish it in after school, I hope that now you get the chance to do so. I miss you guys so much, but things will get better and we'll be able to reunite soon. And in the meantime, take care.